Hello, welcome to our virtual Open Day. My name is Jean-Baptiste Gouillon. I'm an associate professor in science communication in the Department of Science and Technology Studies at UCL. The Science and Technology Studies Department at UCL is an interdisciplinary center studying science as a cultural and social fact. We are one of the oldest departments of its kind in the UK, if not the oldest. We were founded in 1921 and we will celebrate our 100th anniversary next year. We are located at 22 Gordon Square in the heart of London, in the Bloomsbury area. It's a relatively small department with only 22 members of staff and roughly 70 undergraduate students, which makes for a very close-knit community. So what makes the department special? STS is quite unique in combining in one department historians, philosophers, sociologists and political scientists who all study science as a cultural and social fact. We are what we call an integrated center for the study of science and technology. We also have a very strong focus on public engagement with science. We regularly work with different communities around the university in London and in the wider country. Our location in London means that we have very strong connections with key institutions like the Science Museum. One of our modules is taught by people at the Science Museum. We regularly make trips to the Science Museum. What also makes STS special is the way we teach. It is a research-led form of teaching, which means that we try to integrate our research. All the members of staff are research active, and they all integrate research in their teaching, and we also try to integrate students in the research culture of the department. I think the best way of summarizing what we do is that we teach critical thinking, and essentially what we do is asking questions. Questions we ask are, for instance, why is there still a debate about climate change? You may have noticed that not everyone agrees with the necessity to do something about climate change. This is a key question we are trying to understand. Why is it the case? We also question whether science is necessarily good for our health. Recent developments in medicine and medical research, such as gene editing, ask ethical questions about what it means to treat people and cure diseases. We ask if technology is necessarily good for the world. One of our member of staff, Dr. Jack Stilgo, is a recognized expert in artificial intelligence, and we look at, for instance, whether driverless vehicles are a good thing or not. We offer 2 degrees, one in the history and philosophy of science, the other one in sociology and politics of science. Our 2 degrees are structured roughly in the same way. For one thing, the first year is common for both degrees, which means that students are invited to embrace the integrated nature of the work we do in the department. So every student starting in the first year of their degree will be exposed to the history and the philosophy of science, to sociology of science, to politics of science. And then in year 2, the 2 degrees diverge, where that's when students can start tailoring their degree to their tastes, needs, interests through sets of options that they can choose from. And in the final year, the catalog of options is wider. But what distinguishes the third year from the 2 previous years is the dissertation. This is a project which students conduct at the end of their degree, and for 3 months they can investigate any topic they are interested in under the supervision of a member of staff. Students usually really like doing this, and they can really study whatever they want. I'm personally supervising dissertations this year about the representation of technologies in the Marvel Universe, or a dissertation on the use of military metaphors when talking about immunology. So this dissertation can be on any subject that you like. Usually students come up with an idea and they approach a member of staff who accepts to supervise their project if they feel that their expertise can help the student achieve a good result with their dissertation. When I talk about the department, I'm often asked by students or prospective students, why should I come and study with you? Where will it lead me? Students taking a degree with us do not learn a job. They will learn skills that they can apply to many different kind of jobs later on. As I said earlier, we are teaching critical thinking. We are teaching people how to write. We are teaching people how to argue. We are teaching people how to interact with experts in different fields and put all those expertise together. So that it means that you can pretty much work in any kind of sector. Our students usually go either to research, education, media and communication, but others also go to finance, business, some work for insurance companies, etc., etc. Our degree will impart you with 21st century skills which will be well adapted to the modern job market, where you will have to jump from one company to the other, where you will have to change employers and practically invent your own job. So thank you for your attention. I will now hand you over to one of my colleagues who will talk to you about our History and Philosophy of Science degree.
Welcome to this introduction to the BSc in History and Philosophy of Science in the Department of Science and Technology Studies at UCL. My name is Professor Simon Werrett. I'm a historian of science and I'm going to take you through some of the basics of this degree. So what is philosophy of science? What does it involve? Well, it involves many different questions about science. For example, why is science so authoritative? Why does it have the power that it does in society? What is it that makes it a special kind of knowledge that has authority? What's scientific progress? Is science always getting towards better and better ideas about the way that nature is? Or is it just different ways of thinking that change over time? Philosophy of science talks about explanation. What is it to explain something? What kinds of things count as a good explanation and what don't? And we look in philosophy of science at competing accounts of the natural world. So when we have two different theories about some natural phenomenon, say the color or light, how do we decide which one is the best one? There'll always be pros and cons to each side. So what happens? What's the best way to go about that process? And we might think about the nature of truth. So a big question. What does it actually mean to have true knowledge of nature? Can you ever even attain such knowledge? So those are the basic questions, but we can also ask much more in-depth questions, and you do that in the second and third years. So for example, we look at things like classification. How do we divide up the world into different categories in order to make sense of it? What's the best way to do that? Is there a natural classification, a way that nature just is divided, or is it always something that we have to invent in order to understand things? Another area we look at is images. Science is not just about writing, but it's also about making pictures. There are scientific diagrams, models, illustrations, and we look at the nature of those images and how they work to tell the truth about nature. Is there a best way that we can produce scientific images? How do different people read them? How do you avoid subjective ambiguities when you make a scientific image? And then another thing that we look at is questions of who is it that does science? So traditionally, science was a very male province. It was something that requires a particular kind of education to do, and lots of people have been excluded historically from the process of making scientific knowledge. So being a philosopher of science in STS is quite a distinctive thing. The way we do it is different to other departments, and I'm just going to tell you 4 ways in which that's the case. The first is that we're really interested in science as a practice. As I mentioned, one can think of science as theories and ideas, but it actually involves doing things. It involves experiments and instruments, and our staff are really interested in that aspect of the philosophy of science. Secondly, because we're a department of science and technology studies, we're not just doing philosophy of science. And all of our staff try to think about their particular discipline in relation to the others that are being pursued in the department. So if you do philosophy of science, you'll also be thinking about history, about social studies of science, about policy, about science communication, about public engagement, and all those things go into the mix and I think make for a very vibrant community. Another thing that we pay a lot of attention to is making our activities problem driven. In other words, we're not interested in just thinking about things in a very abstract way. We want to connect them to real issues in society today, to problems that we face. Our teaching and research in the department is very much geared to thinking that way. And I think UCL generally is geared to thinking that way. So this is a degree that allows you to go out and actually apply what you've learned to real everyday issues in life in a very direct way. And finally, we're a department that encourages you to do research. We're not interested in you just learning what other people have said. We want to hear what you have to say. So all of our teaching involves lots of research and finding out things for yourself and applying what you've learned to cases that interest you and that matter to you. So I think those are some of the distinctive ways that STS operates. So like philosophy of science, if you study history of science, it's a 3-year degree. You go into more depth as you go along. What kind of things do we look at as historians of science? Well, we're interested in the history of theories and methods and instruments. We want to know, how did we get to the understanding of nature that we have today? How did that understanding change in the past? What did people believe about different kinds of natural phenomena in, say, the 16th century or the 19th century? We're also interested in who has been a scientist in the past. So we might look at the famous figures like Newton or Einstein, but we'll also think about who could have been a scientist in the past. Were women excluded from being in science? And if so, why? We look at science around the world and how different communities in different parts of the world over time thought about nature and understood it. And then we'll also think about the way that the public understands science and the relationship between science and the public. Have there been times when science was very popular or very unpopular, and what was going on such that that could be the case? So there are very many different aspects to history of science. It's the history of scientific theories, but it's a great deal more as well. Here's just a quick example of the kind of thing that we look at in history of science. So if you've ever eaten cranberries, rice, breadfruit, coconuts or pineapple, you might be interested to know that there was a moment when people started to trade in those foods around the world. So none of those are native to Britain. They had to be brought here, and someone had to create a world where they could travel from distant places to get to our tables, for dinner. And what you can see here is a gentleman named Joseph Banks, who is tucking into what he called a botanical breakfast. Now, Joseph Banks was a naturalist at the end of the 18th century. He was the naturalist on the voyages of Captain Cook around the world. And he lived in London, and he made it his life's work to study botany and to try to develop this transport and trade in various different kinds of plants around the world. And at the time, people thought this was pretty bizarre. They didn't really understand what he was doing, or they were very skeptical of it. They were very critical of it. And what you can see here is actually a satirical cartoon. So it's someone taking the mickey out of Banks by supposing that this botanical breakfast involves eating all kinds of weird and wonderful animals, things like crocodiles and ostriches. They never actually did this. They would, in fact, Banks would meet with his colleagues and they would discuss botany and zoology. But by making this image, it was showing up the apparently bizarre, novel things that Banks was doing. So what might seem like a rather mundane topic, the global transport of different foods, actually turns out to have very fascinating and very vibrant history through these kinds of images. Now, I said that in STS, we're really interested in thinking about how different disciplines connect and problem-driven research. So the bank story about moving plants and things around the world actually has a lot of relevance to the present day, because there are big debates right now about the ownership of plants and particularly their genes, their genome, their DNA structure. And those are going on as we speak. So the question is, can a company come into someone's country and patent the DNA of a plant, and then say that the people in that country are not allowed to farm it unless they pay a royalty to the company that patented the gene? So there are big questions about the ownership of plants around the world. Who's allowed to transport them, who's allowed to understand them and know them, what it means to know a plant. Does that mean knowing how to cultivate it, or having a genome sequence of it? And that raises all kinds of interesting issues. And those are exactly the kinds of issues that already existed back in the 18th century for people like banks. And so we see how history helps us to make sense of what's going on in the present. So what's it like being a historian in the Department of Science and Technology Studies? Well, I am an historian in STS, and I can tell you that it's a very distinctive and interesting department to work in. As with philosophy of science, there is a really interesting dialogue between the different disciplines that people in the department work on. So sociology of science, philosophy of science, science policy, science communication, science in public, all of these things mix together, and the historians of science work with those ideas, and that gives them a very interesting perspective, I think. Another aspect that's really interesting is that everybody wants to do history that has a relevance for the modern world, for the problems and the issues that we confront today. We're not interested in history for its own sake. We want to try to use it to solve problems that we have to deal with now. So, for example, in my own research, I use the history of science in the early modern period, 16th to 18th centuries, to try to think about sustainability, about environmental issues, looking at the way that people lived in the past as a way to think about how we live in the present. And then another distinctive feature is the emphasis on research. So we're really interested in what you have to say and getting you to apply what we're teaching you to thinking about problems that matter to you. The dissertation is the main place where you get to do that. And over a year, you'll have the chance to research a topic that you're interested in and you want to understand better. And we work with you to do that and think about, in this case, history as a way to solve the problems that you're concerned about.
Hello, my name's Brian Barmer. I'm a professor here in the Department of Science and Technology Studies, and I'm here to talk about the BSc in Sociology and Politics of Science. I think I need to clarify one thing before I go on though. The BSc in Sociology and Politics of Science is not a general degree in sociology and politics. If you want to do a degree in sociology and politics more generally, this really isn't the degree for you. But if you're interested in using intellectual tools that come out of sociology, that come out of politics, for understanding the impact of science on society and understanding the role of science and technology in society today, then this really is the degree for you. Okay, so the BSc in Sociology and Politics of Science, I've listed a few more general questions that we might address in this degree. So in terms of the sociology of science, we might ask, well, how does science, and that includes technology and medicine, relate to wider society? We might ask how science and society actually influence each other. It's not just about the impact of science on society, but society also has an influence on what gets funded, what gets researched, even what type of questions get asked in science. And we try to understand that using the tools of sociology of knowledge and sociology of science. We ask questions about the public engagement with science. We ask questions about how science appears in the media, and also we ask questions about how to communicate science. We also take a look at science in popular culture. So looking at science in films, in literature, and so on. On the politics of science side, which is more generally called science policy, we think about the role of science in government. Where does the government turn to get its scientific expertise? What is the role of scientific experts? Can they be neutral and just offer the facts, or will they always offer their opinions as well as facts? We ask how science and technology relate to big problems, things like climate change, war, population health, and other big problems that are facing society today. We also ask about the public. We ask how citizens can get involved in scientific issues, even if they don't know all the technical details. How do they engage with moral issues that arise from things like genetic engineering, forensic science, or artificial intelligence? Let me take you to a specific example. Should we grow genetically modified crops? This is an issue that has raised all sorts of concerns in recent years. Here is a group in 2012 at Rothamsted Institute in Norfolk who are protesting against field trials that scientists wanted to make of genetically modified crops. So this has become a controversial issue. In recent years, it's become even more controversial as scientists have developed gene editing techniques which can very specifically modify particular traits in crops. They promise that this will help the world. They promise that this will help feed the world because you can grow crops that are in areas, say, that wouldn't normally grow those crops. Salty soils, for example. You can breed the crops so that they're resistant to pesticides, so that you can apply pesticides and only kill off the weeds. On the other hand, protesters have said they don't want these foods. They have argued that they won't solve the problems that they're designed to solve, that actually there are issues around food distribution rather than food production, so that actually there's enough food in the world, but it's not very evenly distributed. It's rich Western countries which tend to have all the food. So here's the same debate taking place on Twitter as well. People saying, let's support the Rothamsted researchers. Don't destroy our scientific research. The protesters were actually arguing that they should be able to take direct action, to go in and actually dig the crops up if the trials went ahead. So this becomes a debate about citizenship. As citizens, are we allowed to take direct action with things that we don't agree with? We're certainly allowed to protest, but can we actually go and uproot those crops? It's a political question, not a scientific question. I want to think about two different perspectives on the problem. One is to look at this as a purely scientific problem about genetically modified crops. And this is summed up in the words of Sir Paul Nurse, a leading medical scientist, even though he's not specifically talking about genetically modified crops. He says in his Dimbleby lecture in 2012, when Galileo argued that the Earth orbited the Sun, the Inquisition did not argue back with science. They simply showed him the instruments of torture. It's very important that we keep such influences separate from scientific debate. The time for politics is after the science, not before. So here is a leading scientist saying, first you do the science, then you do the politics. First you come up with the inventions, then you decide what to do with them. But the problem there is that actually science and politics and science and society are deeply intertwined. Questions about what we might see as desirable science are also about what we want the world to look like, what we desire science to look like. And this demands a much broader approach. One leading science and technology studies scholar who specialises in the sociology of science and in science policy is Helga Novotny. As long ago as the year 2000, she was writing about expertise as transgressive competence. Now, what does that phrase mean? What she means is that we need expertise that crosses boundaries, crosses disciplines. Narratives of expertise are transgressive, she says, in the sense they must respond to issues and questions which are never only scientific and technical, never only scientific and technical. So how do we think about genetically modified crops as demanding transgressive expertise to think about the debate? Let me show you. Back to Paul Nurse in the same lecture, a scientist speaking about these things. And I should add, a very respected scientist, so it's not just anybody speaking here. It's time to reopen the debate about GM crops in the UK, but this time based on scientific facts and analysis. There is no room for preconceived ideas First we need the science, then the politics. So he repeats that same line. First the science, then the politics. Separate them out. First the facts, only the facts, and then later on we apply our politics and decide whether we want these GM crops or not. Contrast that with Helga Novotny. Helga Novotny isn't saying that Paul Nurse is completely wrong. Of course we need science and we need scientific facts. But she says we need this transgressive expertise. We need a little bit more than just the facts. We need to ask questions about the physical risk, which does demand science. Will GM harm the environment or health? That's what we call a risk to ourselves, our physical risk. If I eat a GM crop, will it make me ill? Will I die? Will it damage the environment? Of course, there's a role for science in that and in those debates, although there is still a role for us to understand how those debates are conducted from the perspective of sociology. But there are other questions. Will it benefit developing or developed countries? As I mentioned earlier, is there enough food already, or is it just poorly distributed? Well, that's what we call a social risk. It goes beyond the science. It's more than the expertise of a scientist that is needed to answer a question about how well food is distributed. Who will it benefit? There's even what we might call political risk. As citizens in a democracy, do we get a say in any of this? Is it just big multinational companies or scientists who are charging ahead without consulting anyone? Well, that's a political question. It's about democracy and how we operate in a democracy. So don't I get to choose what or have a say about what I eat? How much science do I need to understand to participate in those debates? Those are the sort of questions, that's the sort of expertise, that transgressive competence that a degree in sociology and politics of science is trying to equip you with. So just to finish off with, I just want to take you through the sort of things you might be studying if you take a degree in BSc Sociology and Politics of Science. In year 2, we build on the skills and the knowledge that you've had in year 1, but we start to narrow things down a bit. You will have some compulsory modules, one in research methods, how to conduct interviews, how to do a survey, how to go about finding out about science and society. You'll also do a compulsory module in sociology of science, thinking about where science fits into wider society. This builds on the second year, but also thinks about the sociology of knowledge. How do we understand knowledge as embedded in society? Why do we ask certain scientific questions at particular times, in particular places and not at others? And that's part of the sociology of science, building on what you've done in the first year. There's also optional modules. Policy issues in the life sciences looks at issues that I was talking about just now around things like genetically modified crops, biological weapons control, animal experimentation, human experimentation, and other issues that arise out of the life sciences. There's another option, science in government, which looks at the role of science in government. It involves a trip to the House of Parliament and to look at how science is involved in Parliament, in government. And there are other module options as well that you can take in your second year. Your final year, your third year, is your specialist year. You get to pick options in a range of very specialist modules. I've listed some here: science and war, one that is about governing emerging technologies, thinking about new technologies, technologies which are just over the horizon, thinking about the future, but thinking about the social and ethical issues that arise out of those new technologies. Or more practical courses such as science journalism, and of course I haven't listed there science and filmmaking. One of the big things that you will do in your final year is a dissertation. This is a 10,000 word research project with one member of staff as your supervisor. In past years people have picked all sorts of topics, but just to give you a few examples, this year I'm supervising a student who's very interested in technologies that might be implemented on the border between Northern Ireland and the Republic of Ireland after Brexit. There's been a lot of talk about these, but no one's actually been able to come up with any specific technologies. So why has that happened? And what role do these absent technologies have in the politics of science and technology? Thank you very much for listening. We're now going to have an online Q&A session, a live online Q&A session. So if you want to join that, and we hope very much that you will do, please click the link below this video. Thank you very much.